Hello, everybody, and welcome. It is still Advent of Code, and it is day 10. I'm so excited to be back on this wonderful Tuesday. And of course, I am very excited that all of you are back as well and are tuning in, still holding strong after all these programming puzzles. Lots of twists and turns. So, if you are here, if you're in the chat, say hello. Just like Maya is doing right here. Hello, hello. Good to see all of you. And of course, I'm also very interested in how you felt about today's puzzle. If you remember, yesterday, I said I'm gonna put the Mazes for Programmers book under my pillow in the hopes that I would maybe absorb some knowledge for today. And I mean, we can argue about what kind of algorithms we'll use later on, but I feel like some sort of traversal of a maze-like structure was certainly given. I am not sure, however, if I've absorbed anything just by osmosis from the book, or whether I just remembered. You have inside information? That's a bold accusation. And I guess it's not helping that I already prepared the scaffolding for my day 11. So you'll see that in the sidebar. I am not a time traveler. See, here's proof. My day 11 so far just reads an input. It doesn't do anything else. So I wish I had some extra knowledge, but alas, I am stuck with the same info as you are. You've absorbed the knowledge from previous years of Advent of Code. Yeah, that might very well be the case. There is a certain repeating pattern that happens to be the overarching categories of what the solution might be, though sometimes they do throw in some twists that have not been seen before in the same way. From what I heard, I was one of many people that accidentally solved part 2 first today. Interesting. Wonder why that happened. Oh yeah, I solved part 2 before even unlocking it. Very nice. I think depending on the approach that you take, today was one of those days where, at the very least, part 2 was something that could be solved with just a couple of lines of code changes. I mean, for me personally, I could look it up for a second here. It was certainly not my fastest delivery, but yes, we can see that the difference between part 1 and part 2 is like 5 minutes. That's just me copy pasting and then being confused by my own copy pasted code for a good 4 minutes. But yeah, that maybe gives a bit of a hint. For my part 2, I simply removed distinct. Yep, those are those small changes. Not hard, but they took me around 1 hour both. I have to admit, I'm in this conversation with a colleague of mine, with a friend of mine who happens to solve a lot of these puzzles in Rust as well. We've already seen Rust a little bit earlier, a couple of days ago, and their pathfinding crates are surprisingly powerful. So if one was to say, for example, "Oh, I just need a Dijkstra," they do have quite a lot of convenience functionality that's just out there. But today is not about Rust. Today is all about Kotlin, because this is Advent of Code in Kotlin. And if this is the first stream that you happen to catch, or if you just like me saying the same thing over and over again, I'd like to once again direct you to the Advent of Code 2024 in Kotlin blog post, where you can find information about everything that's happening. You've already found the streams. Congratulations. In that blog post, you can also find our leaderboards. And whether you are competing for a top spot or just solving a couple of problems, as long as you're in the leaderboard, you have a chance of winning some exclusive Advent of Code in Kotlin swag. It's good stuff. And, I really like having it around my place. So, you should really go for it. My current mug today is not an Advent of Code mug specifically, but it is a Kotliners 2020 mug from an entirely different era. What a different world it was. Yeah, apart from that, we also have a bunch of resources, including templates. If you're feeling adventurous and you'd like to try the new build system that we're building at JetBrains, check out the Amper-based template, or just use the Gradle-based template to get some scaffolding for your solution. And of course, I will be remiss not to shout out our AOC 2024 in Kotlin GitHub topic that you can add to your repository right now, which means it will show up on this wonderful site, where we now have 863 public repositories that are all tagged as AOC 2024 in Kotlin. Not only does this allow you to discover other people's repositories and things like the templates, it also gets you a chance to potentially win some AOC swag. So, once again, very much worth it. And I really loved seeing those numbers grow over the last couple of days. So let's keep that trend going. If you haven't tagged your repository yet, this is your call to action. I'm very excited to see that there's already a lot of people who are comfortable with their solution for Advent of Code this year. And I'm very excited that all of you decide to do them in Kotlin alongside us here, of course. So I am very delighted to have a very special guest today, which you can already see in the stream title, is Dima Jemerov. Hi, Dima. Welcome to the show.
Hi, Seb.
It is so good to have you because, I mean, we're talking about Advent of Code in Kotlin here, and I think you are probably intertwined with the story of JetBrains and the story of Kotlin like few others are. I've just pulled up your homepage here. I hope you're comfortable enough with your web design skills that goes out in front of other people's eyes here on the broadcast. But yeah, you were the team lead for the IntelliJ plugin for Kotlin. Among other things, you wrote the first edition of Kotlin in Action. That's a torch that I then luckily had the chance of continuing to bear with the second edition of Kotlin in Action. And we should not forget Svetlana, who wrote the first edition together with me, and she also participated in the second edition, I believe, as well. Absolutely.
Yeah. Absolutely.
I mean, in your videos and interviews section here, you are titled as the godfather of Kotlin, which now that's a pretty cool title, I'd say. Do you want to just like quickly sketch maybe just like how you're connected, how you got to the point of like leading things and really influencing the language, so that people maybe have a bit of an idea?
Yeah, so in the very beginning, basically, Kotlin started with a conversation between me and Sergey Dmitriev, who was then the CEO of JetBrains. So I had an idea that it might be cool for JetBrains to build its own programming language. Back at the time, we had a bunch of ideas for different languages. And so Java, Scala, Python, Ruby, .NET, of course, C#. And basically all we were doing was building tools for other people's technology stacks. And I thought that it might actually be cool for us to have our own technology stack. And because the products that we were building, the IDEs, they were not really like something that many other people would need to build. So we could not really extract a framework out of the IDEs. But I thought that this experience of building IDEs would get us enough understanding of the problem domain and also clout, if you want to put like that, like credibility in the community, so that we could actually pull this off with building a programming language. So I was like, after this conversation, like a bunch of these things started happening that I was not heavily involved in. So the actual design of the language was not done by me. It was Andrei Breslav's work, and along with a bunch of other people. But I joined the team to work on so my first contribution to Kotlin was the Java bytecode generator. So I was actually the first ever Kotlin programmer, because the first ever Kotlin program that was compiled to Java bytecode and ran, it happened on my machine. And after that, I gave the name to the language. That's why I'm the godfather. So at one point, Sergey just basically came to my desk and said that we need a name. And back then we had like a code name, Jet Language, which is like not very interesting name. And so he said that we need a name, and he was just standing there and not leaving, apparently, until I came up with a good idea. So I had to think of something. And back then, Ceylon was also a language that was talked about quite a bit. And like, so there was a Java language named after an island, and the Ceylon language named after another island in roughly the same part of the world. And I thought that we also have an island next to the place where we were, next to St. Petersburg, which is Kotlin. And this also kind of sounds simple enough to spell and catchy enough. And I thought that, yeah, this could be a good name for a language. Back then, back then I was really concerned that maybe the German people would not define the name as cool, because Kot means dog shit, basically, or like shit in German. But once I saw that next to our office building in Munich, another one was built, which was called Trikot, I kind of stopped worrying completely about this. But this is the specific reason why the extension of the Kotlin files is .kt and not .kot.
That's actually very good to know. I did not realize that was part of the consideration.
Yes.
But hey, it makes a lot of sense. And I mean, fast forward to nowadays, like I guess all of those decisions and all of that has really it really did bear fruit. And so I mean, in hindsight here, I can say thank you so much also for giving it such a catchy name, and diving deeply enough into the language so that or into languages in general, that we don't end up with an extremely awkward file ending, which is actually maybe my segue here, because when we look at your website, we see that it does say software developer, but the first thing you say you are when you introduce yourself here is a linguist, and I'm very curious about what's up with that.
Yeah, so basically, I left JetBrains some time ago, and this year I've started studying in the Leiden University, and I'm studying basically. This year I'm doing a pre-master in linguistics, which is basically an abbreviated bachelor's course, and next year I plan to do a master's in comparative Indo-European linguistics. So basically, studying the origins and the interconnections of all the Indo-European languages, which are the language that we speak right now, and many related languages, and dead languages such as Latin, Greek, Hittite, Luwian, and Tocharian, and a bunch of other things. And I'm just really interested in how language comes to be, how grammar comes to be, how this all evolves, and how the things that we take for granted nowadays, how they actually appeared over the course of the centuries and millennia of the language evolution.
Now, I'm very curious here. Is this something that has been a part of your whole life? Is this something like linguistics or an interest in linguistic? Is it something that you, I don't know, like picked up as a hobby, like throughout your career, kind of as a side thing, and then decided, hey, this is what I want to spend all my time on? Was it maybe the other way around where you just said, hey, okay, I've done a lot of software development, what's another like really big challenge for me? Like how did this come to be?
So I've actually been interested in linguistics for most of my life. So my first encounter with it was when I was, I don't know, 5 or something, or 6. We had basically a really good book introducing linguistics as a discipline that I read as a child. Then a few years later, I started studying in the classical gymnasium, and the program, like the classes in the classical gymnasium, include 6 years of Latin and 4 years of ancient Greek. And this kind of, while studying these languages, you get a really foundational understanding of many of the core concepts in linguistics, like syntax and morphology, and also a little bit of how this evolves historically, because if you know Latin and if you know like a language such as Spanish or Italian, you can actually see very easily how that has evolved from Latin. And after that, I actually considered doing linguistics as my first university education. Back then, I decided not to do this, but the desire to dive deeper into it was with me for like most of my life.
That's so cool. And then of course the other probably natural question to ask is you have a super extensive background in software engineering. So I'm just curious if that at all comes in helpful at any points when you're looking at linguistics, when you're trying to learn to study. I can see that you have a personal project that mentions a linguistic database, but I just wanted to open up that question.
So in fact, this thing that I'm doing, the linguistic database, is kind of a toy project, and the way I'm doing things there is not very much alike how most people use computers for doing linguistics. But I still want to go down that path and see where it leads. And so far, like, basically, my biggest research question is, when will I hit a dead end with this approach? And I've been working on this thing for 2 years now. So far, I haven't encountered any dead ends. There's a lot of space to explore, and I surely hope that it will stop being just a toy project and will actually become useful for actual research. But we are not at that point yet.
Hey, but that's extremely cool. So it especially given all this context, I'm even more glad you decided to return to your Kotlin roots here and come join us on the official Kotlin YouTube channel. So I'm excited to see the godfather of Kotlin in action, and for that we of course need a little bit of a puzzle. We're gonna jump right into that in a second with my wonderful reading hat here, but this is also once again my point where I'd like to shout out that we at JetBrains are indeed sponsoring Advent of Code. We're very excited to be one of the supporters of an initiative like this that helps people engage with problems and further their programming skills. So let's let me put my little hat on here, which has so far been proven helpful in solving most things. I have gotten all the stars that are available so far. Correlation or causation, I do not know. And we are diving into day 10. Hoof it. You all arrive at a lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can help build the missing hiking trails? The topographic map indicates the height at each position using a scale from 0 lowest to 9 highest. For example, 0, 1, 2, 3, 1, 2, 3, 4, 8, 7, 6, 5, 9, 8, 7, 6. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, or right from the perspective of the map. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. Assembling more fragments of pages, you establish that a trailhead's score is a number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9, the one in the bottom left. This trailhead has a score of 2. So here we have 0, 1, 2, 3, and then we have legal steps 4 in either direction, 5, 6, 7, 8, and 9, all the way to the summit. The positions marked with a dot are impassable tiles. To simplify these examples, they do not appear on your actual topographic map. This trailhead has a score of 4 because every 9 is reachable via a hiking trail, except the one immediately to the left of the trailhead. So the only one that we can't reach is this one right here, because there is no individual step that leads us up there. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. So here we have this trailhead, which leads us all the way to this summit, and then we have this trailhead, which leads us both to that same summit and to the summit up here. Here's a larger example, and that larger example has 9 trailheads. Considering the trailhead in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. The reindeer gleefully carries over a protractor and adds it to the pile. What is the sum of the scores of all trailheads in your topographic map? Dima, I happen to know that before you moved to Leiden, you spent a whole lot of time here in Munich, and we are quite close to the Alps, so this puzzle seems almost like it's made for you. Lot of hiking related things here. Did you have an immediate thought when you read this puzzle?
You mean about the solution or about like the hiking in general?
I mean either.
Yeah, I don't know. Like I know how to approach the solution, so I'm not doing the full AOC this year. So like I will just do this one task. But there have been many similar tasks in the previous years. Yeah, and of course where we live, basically the array of heights of the Netherlands basically has the value of 0 all over the place. So like,
okay.
It's funny that like in one of the districts of the Netherlands, the highest point that exists is just basically there's a landfill, and basically the highest point of the landfill is the highest point in this particular region of the Netherlands. I find this quite funny.
That does not sound like the world's greatest hiking destination. I will admit.
No, it's not.
Okay, well then I'll throw it over to your screen here, and you can walk us through some virtual hiking and map creation here.
Yeah, so I genuinely have I will actually I don't have a solution, so I will just walk you through it as I'm solving it live in real time. So what do we need first? First, let's start with the map class. Let's just do this. And the map is, let's start with the unit test. I like writing unit tests. Equals map dot parse, and then we will just pass in this in the nice tribal code. Yeah, this is the first. Yeah, this will do.
I just want to let you know that your input will not contain dots. The real
I know,
input will be all numbers. I'm just letting you know.
I know. Actually, should I do the trim indent thing, or let me do it like this, and a trim. Will this do the right thing? Do you remember?
It should, yeah.
Okay. Let's see if there should be 6 in the position x is 0 and y is 3.
It seems you have also cut off the last 9 from your input. There should be a 9 as the very last character.
Yep, thanks for noticing.
Yep.
Okay, so there is no parse method. Let's create one. I don't like this suggestion, so this is map text, and it returns a map. And I will going to split it by map text. So it's split using the line break as a delimiter, and it's lines map. It dot I just do another map. So like I get a character, and if character equals dot, this will be -1, else d -0. This should be correct. So, and okay, so this, yeah, a list of int is not really optimal, but let's live with that for now. And now I need to create the add method, x and y. So like, so this needs to be a val, right? Like the first is a line, so the first is y, and the second is x. Yep, the test should pass now. Nope, it doesn't. Expected 4, but was -16. Okay, so let's do a quick debugging loop. Why did we get -16 where we were supposed to get? Let's see if we get the first one. Let's see if the map, if the trim indent did not do what we needed to do. So we let's do this.
Oh, it's just because the first line you need to move it down by 1 because it's the common minimal indent of all input lines.
Yep.
Yeah.
And now it will there will be a blank line now. So
trim indent also removes the first and the last lines if they are blank.
Oh, wonderful! Then it should work now. Yep. Great. Okay, now let me do the static import here to make it a little bit nicer. Okay, now let's jump a little bit up a level and trail score. Let's do the trailhead score. So we'll use the same map. Let's introduce a constant, extract constant, map1. No, this is not the collections map, this is my map. Why is the plugin doing the wrong thing for me? So the trailhead score of the expected trailhead score of 2. Trailhead score. Yeah, of course, if I was doing this for actual competitive programming, I would not do this with unit tests and stuff. But like, since we have time here, and I think it's just more interesting to show like this particular way.
I think this is a great way, and people are already very, very excited about the TDD real-time solving you're putting on here.
Yeah, so I don't know why the intention to create a method from usage doesn't work. I guess it probably should not be a trailhead score. So let's do this like this first, and this will fail. Okay, so how do we calculate the trailhead score? So in order to calculate the trailhead score, we need to basically iterate all possible paths. So I'm actually, like, having read the discussion in the chat, I kind of can foresee what the second part of the task will be. So I'm going to like solve this the way right now. So basically, I will just we'll just need to collect all the paths from the trailhead and then calculate the distinct endpoints of those paths and then calculate how many of those they are.
By the way, you did not add an add test annotation here, so that test did not actually fail yet.
Yep, good point. Yeah, I haven't even run it yet, actually. So, okay, so this is basically, let's convert what I just said into code. So, so like the path will be a, so let's add the point class. So basically a path will be a list of point. So like this will be the starting point, and the result will be a list of point. And this will be an empty list. And I need to create the point class here. So I'm still getting a 0 return. Yeah, let's deal with the find trails thing. So like basically, how do we follow a trail? We follow a trail by so like we actually need to have a recursive function return find trails from the start. So like basically, okay, let's do the iterating the neighbors first, because I know we need that. And let's also unit test it. Neighbors. So we'll have another map. This is not Kotlin collections map. I guess if I should, like, if I add the package statement, I think this will work better. I hope now it will be a little bit less crazy. So from the point of like 1, 1. Okay, now we can create a member function, and this will be a list of points. This, of course, I'm also not worrying about efficiency. So like all this, data structures getting created and garbage collected in a real program, you can do this much more efficiently. But thankfully, we don't have to do this. Or in like this is like really inefficient. Don't do this in production code. -1 and 1. Let's do it another way. No.
You could just wrap a build list around this.
Yep. Let's like do it like that. This is the way I usually do it in my code. And return result. And I'm intentionally making it incorrect so that I can write the failing test later and see it. So like do the simplest thing that possibly worked, then run the test, then write another test, and then make this actually proper. Point x plus dx, point y plus dy. Yeah, this should so like this 0, 0, this means 1, 0, 0, 1, 0, 1, 2, 0, 1, and 2, 1. This should be correct. Okay, so this is not in the neighbors. Interesting. Why is it not in the neighbors? Yeah, because I wrote it because it's actually wrong, and let's just do the simpler thing. I was being too smart for my own good. Good thing we have tests. Okay, now it's just the Trailhead support test that is failing. Now the part which I mentioned was incorrect is why is it in column selection mode? I don't want this. How did I manage to turn it on? I'm still getting this bogus Kotlin collections.map thing. Now I guess the point is 0.0, and there should be 2 neighbors. I'll 0 and 0.1. And of course, the more now I'm going to show a little trick that I really like to use, is to use a local function here, because we actually need to do the range check. Range, because like this makes sense only in this context of this particular function. So if text So like the width of the map is the length of the first array of heights, and the height of the map and is the array of the heights as a whole. Okay, and then I could just replace this with. So there should be a way to do that. Do this manually. There is a way to do this. Like there's this nice feature in the latest IntelliJ, it highlights on all the occurrences, and I don't know how to use it all that well. So like, okay, now it's all broken because I mistyped the sign. Okay, now it's not broken. Wonderful. So then let's write a follow trail function that basically follow trail is takes a coordinate. Basically, so what I want to do is just basically get a list of the directions from a given point in which I can follow a trail. So we can trail. So also I'm going to follow the trail from this. So like this is 3, 0. And I don't actually need to pass because I know the height. I should do a setup. No, I don't need to do a setup. And there should be 1 point. And the coordinate of this point should be and the first point is I can actually make this like this. Just use the single, and then I don't need a separate assertion for the size. Then I can write the follow trail function. And then let's just return a list of points. And it's actually very simple. So basically I need in if at so I should actually just do this. Just do this with a point. This should have been a separate refactoring step, but if I'm cutting some corners here.
That's okay. AOC is all about coding crimes.
So also one other nice, so typically if I was implementing like a search algorithm right like that, I would need to keep track of the points that I have already visited. But thankfully, because I'm already because the only point that I can visit is the point where the height is the height of the previous point plus 1, I don't actually need this track because so like this step-by-step increase of height already guarantees that I will not end up running in a loop. So like it's even simpler than a typical search algorithm. The result. This should actually be this can actually be so much nicer. This should be just be a filter call. I don't need this mutable listing. Yep, that's basically the essence of what I'm doing. Now let's random test. I did. Set equals. Okay, wonderful. So now I can follow trails. Now let's write a second function, because there is one place from which I can follow trail to multiple directions. So like this is if I'm following the trail from this point, which is 3, 3, then I can actually go to multiple directions, and I need to make sure that I actually get 2 points back. I would just basically, I'll just make sure that it returns 2 points. Okay. So now I actually need, so now I can follow the trail, and basically, how do I do this? So basically, I need to let me try this. So I'm trying to figure out how to represent it. I'm actually like the set, like for each branch of the trail, I need to basically start 2 paths of recursion. So I think we can do it like that. So basically this will be a mutable. No, so let's. So basically, like this is like the list of trails. So like, so this is a list of trails. List of point. I'm going to make trail equals a list of point. I'm just doing a type alias because I don't actually need any behavior on this class, but this makes it easier to reason about this thing. So like this is a list of trail, and this is a list of trail, and I forgot the parentheses, and this is an empty list. So basically now so basically every step, then basically I need to do the extended trail step 10 times. So I can just, because I know that the maximum height is 9. Is it 10 times or 9 times? It's 9 times. Is it? No.
Dot less than, yep.
No, it's actually, yeah, that's correct.
Alternatively, repeat 9.
Yep, right. Got this.
Repeat 9 is just takes the lambda directly.
Yep. So basically, so I need to seed this with like result, add. So basically the trail start with the trailhead. So there's a single trail, and that has a basically we have a, so now like 4. So this is actually not like that, but rather like that. And now, so basically I'm going to walk for each trail. I'm going to so I'm going to let map. So basically for every trail, I'm going to so like the I'm actually trying to do too much right now for a TDD. This would have been much easier. This would be easier if I had the simple, if I had the test step by step. But let me try to finish this as it is now. Val up equals follow trail. Trail.last. So if is not empty, so basically if there are points with the height 1 more week that we can reach from this trail, so if there's then basically for for every point in the follow up, we create a trail and add the next step. Wonderful. This is such a nice feeling where you get all the bunch of red code and then you.
It is very satisfying. I always hold my breath for a brief second there.
So basically, like we have basically at every step of the way, like before the loop, I'm just going to talk through it to make sure that it all makes sense. So like basically these are the trails that we have found so far, and on every step of the way, like the trails are all distinct because the procedure that we use to generate it ensures that we don't end up with like multiple copies of the same trail. But it will, if there are multiple paths that we can take to reach a given point, then all of these paths will be in the list. So basically, we take a trail, we follow it from its last point to the next point, and the trail by construction has at least 1 point. So if we reached any point, so if there are any neighbors that have the height of n+1, then just we generate a new list of trails which have been expanded by this 1 point. And this plus operator is very handy because it can be used to construct a list of these elements and this one additional element. And if there are no neighbors with the height of n+1, then basically this trail was a dead end and we do not include it in the next step. Let's see if it works. It doesn't, because we didn't actually implement the logic. I'm foreshadowing here. Map to a set. The last point of each trail. And the size of this. Okay, as I said, this was too much because now the test is failing and I don't want to run it in the debugger. And so let's try to.
Your return statement is just empty list.
Oh, yeah, thank you for
that.
Yes, that explains it.
Oh, saved.
Yeah, thank you. I was actually I should still do the refactoring because it would still improve the code a lot. So, do we want to do this one now? Now we can actually try to calculate. Yeah, let's do this map and then let's try to write the total score. Constval. Let's put the trim indent here to make it more. Why does it hate it? Ah, because it's not constant anymore. Understood. Okay, this is good enough. Trailhead score on map 2. So like if we start at the bottom, so this, okay, if we start at the bottom, this is 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5. No, this is also 6. So if we start at 6, 6. No, it's not 6, 6. This is so impractical. Yeah, okay, let's calculate the total score. No, let's do this. Let's do this first. Head score of, this is like x is 1, y is 0, and let's actually do want to count how many this is. 1, 2, 3, 4, 5.
It's 6, 5 are the indices, by the way, for the bottom one.
Yeah, thanks. 5. Okay, then I don't actually need that. I wanted to assert that we want to start at a point with a height of 0, but
sorry, it's 5, 6. I said the y coordinate first.
Yep. Wonderful. Let's now just let calculate the total score. So basically just so basically so this will be the y coordinate, and I'm using the, so I'm first of all I'm assuming that all lines of this are the same length. So, and this will be the trailhead score of x and y. Then I need to sum this, and I need to sum this as well. And this change return type to int. Okay, thanks IntelliJ. I didn't remember that this was the sum of 9. Why is it 9? Because I'm taking the points where the height is not 0.
Mm-hmm.
That equals,
It's just a closing paren, I think.
no,
Like the at function just takes a
right. Wonderful. So I think we have the first time part solved. Okay, so let's now write the scaffolding. While txt read lines map equals map parse lines. What's wrong with that? Read. Don't actually even need to read text. This should work well enough. I'm running the wrong thing. Now I need to run this thing. Run. Okay. What's wrong with the map? Let's see what the map looks like. Oh, there's an empty last line. That's why it's broken.
Oh, okay. So I guess just a quick trim after the read text.
Yep.
Oh.
Let's see if I got this right. Yep.
Oh, look at that. Very nice. I have to say, what I find quite funny is that you did mention, like, very early when you looked at the problem, you said, yeah, like this is like recursion, or
Yep.
this is typical recursion. But one of the fun parts that I did notice here is that at no point does your function call itself.
Yeah, true. So basically, like, we don't actually need the recursion because we can just do a step-by-step walk because, like, we know how many times we need to step down the path.
Which is that's a very cool generalization, or that's a cool insight to gain just based on the input. I have to admit, I did not quite have the same insight when I wrote my my answer this morning. We can actually take a brief look before we move on to part two.
Let's
here.
look at it. Yep.
Let me just move here to my entry point. There we go. I'm just gonna bring this one up. So first of all, we build ourselves the map from lines. This isn't particularly interesting. I just use the build map function here because I really like the combination of builder functions because I can still do all the loops and I can still do all the kind of mutating operations on my mutable maps. But naturally, even if I didn't specify the return type here, what I get back from the builder is always a read-only version of that map. But yeah, this essentially just puts everything into the data structure that I happen to use, which is a now Kotlin collections map, not a custom data type here, of locations to heights. That's pretty much all that does. And then I'm like, okay, where can my trails start? Well, wherever my value in my map happens to be 0. This is probably a premature like filter. I could also just, like you did, just override any kind of paths with a sum of 0 if it happens to be a different height. But yeah, then from there, I have all my starting points. I have all the 0 height points, and I can sum up how many summits I can reach from that given trailhead. How do I do that? First of all, I'm being a little defensive here because sometimes I do not trust the method I wrote like 2 minutes ago. Maybe I would have more confidence if I had just written a test, but this is close enough in the mornings.
This is a good practice.
Yeah, so I just make sure that trailhead is actually at height 0 in the given map here, and then I do some sort of walk to the summits, which gives me back a list of reachable summits. Summit in my case here, just like your type alias for a path, I decided I was just going to throw in a quick value class here, so that I get a little bit of extra type safety for myself. But I don't have any runtime overhead. Of course, that constrains me to actually just having a single variable, or a single constant in my case, I suppose, inside that value class. But that's more than enough here, and it adds a little bit of readability.
Value classes are a very new feature in Kotlin, and the kind of at some point I stopped following as closely, so I'm not really. This is not part of my day-to-day lexicon.
Yeah, no, of course, but yeah, as someone who keeps on promoting all the new language features, I just gotta throw them in wherever I can.
Of course,
yeah. So we'll take a look at how we get there, but you can see that even after that, I need to be defensive again, and I need to make sure that all the summits at that location actually happen to be at height 9, just to be safe. And then we also do this distinctness check that you did by mapping it to a set. For me, I'm just like, it's called toSet. and I get the size. So how do we walk to a summit? Well, walk to a summit now is a real recursive function, as indicated by the little recursive call indicator over here. And essentially, it takes a path that we've walked so far in our original invocation that's just going to be the trailhead. And it's going to return the list of summits. And here, before I even think about any of the logic of my recursion, I love writing myself a good base case. So I grab myself the current location, which happens to be the last part of my path, whatever node I visited last. I'll see what kind of level I'm at. If that level happens to be 9, that means we have reached a summit. So I can just return the list with the single element of the summit at the current location. If that's not the case, I can increment my current level by 1, and I can try to figure out what other locations or what other nodes I can recurse to. This is essentially just a very semi-convoluted way of getting all the neighboring nodes. But I did actually, full disclosure, while I refactored some of the other code, this is original like 6 a.m. style code, because I was just like, I was just like, I don't want to write like current location dot up, current location dot down. So I was like, okay, I can just turn the current location into the receiver of this block that I've added here, and that means that I can call these little convenience functions that I just stuffed into my vector2 class for up, down, left, and right. I can just call them here. And
so you're not actually doing the range checks. You're actually because you just have a fallback saying that. So you basically anything outside of the map has infinite height. This is
yes. So this is and long-time watchers will know that this is a certified Sebastian AOC classic. A function like this, I think, has come up like 5 or 6 times so far. My default is always I don't like doing bounce checks, so instead, if I can just provide a default value, I always do that. I think the last time I had like if I just look for the question mark character, like I had like a get tile function, which was just like if I'm out of bounds, it'll just return a question mark, which will never interact with anything. Otherwise, it'll return the actual value. So yes, this is something where I try to be a little bit sneaky. Essentially, if I take a look at the get coordinate function, I added it to a comment. This happens to be a very, very steep cliff that you have in front of you, just of height 2.1 billion. Yep. So with that out of the way, we have our next. We have the actual coordinates that we can visit that are one step up, and from there we do the recursion. So we just say that once again our reachable summits at the end are all summits that can be reached from one level up if that level happens to be reachable, and we return that at the end. So that's my approach here. This one with real recursion, but I have to be honest with you, I really like your solution. I like this manual, like taking a step and then just collecting like the new places and then iterating again. I think that's very, very elegant. But it got me to the solution. So that's great. Okay, well, let's see what things might await us in part 2. The reading hat goes back on, and we'll see if we have programmed ourselves into a corner, or if we actually, have an approach that generalizes at least far enough to solve part 2 quite quickly as well. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead, called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. For example, in this scenario. The above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. So we can either take, in top-down view, a left turn and then go all the way down. We can go straight and then take the left, or we can take the lower left turn. Here's a map containing a single trailhead with rating 13. So we have 13 distinct ways of getting from this 0 to any summits that are here. This map contains a single trailhead with rating 227 because there are 121 distinct hiking trails that lead to the 9 on the right edge and 106 that lead to the 9 on the bottom edge. Here's the larger example from before. Considering its trailheads in reading order, they have ratings of 20, 24, 10, 4, 1, 4, 5, 8, and 5. The sum of all trailhead ratings in this larger example topographic map is 81. You're not sure how, but the reindeer seems to have crafted some tiny flags out of toothpicks and bits of paper and is using them to mark trailheads on your topographic map. What is the sum of the ratings of all trailheads? Okay, seems like a little bit of a twist on our original problem, but nothing that seems unsolvable. I'm just gonna throw it right back into your IDE here, and you can just continue.
Yeah, this, I must say, this was foreshadowed. So, I always like foreshadowing. It's a great part of storytelling. So let me grab the map. Let me grab this nice, simple map. And let's write a test for the trailhead rating. Trailhead rating. And this time it's map 3. And the total trailhead rating, do we need to, what's the trailhead total score? Oh, we can do this. I love this. Let me refactor this first. So I'm just going to refactor. Basically, I'm going to extract this particular thing into a lambda. And actually, can the IDE do this for me? Why did my column selection mode again? We had this refactor in Java where you could say refactor extract lambda parameter. Okay, wonderful. It actually did the right thing. How amazing is that? It almost did the right thing. But it actually... so these functions now actually should be called enumerate trailheads. Okay, so and now also I need to fix the main function. Okay, let's run the test to make sure it still passes. Yeah, the trailhead rating is... Yeah, this is just wrong. Now I can create a create total head rating method. And This is also a numerator in here. Yeah, this function can be private. Good hint, IntelliJ. Numerate trailheads. Head rating. Oh, oops. No, it can, the IntelliJ can't figure out what I want from it. It's fine. So let's start with returning 0 for now. The test will fail. Test will fail. Test has failed. Is the rating actually? No, the rating is not 1. The rating is 3. Still fails because we still haven't written this. What can we? So it's just basically the size of paths. Okay, let's try the. So the test fails. I hope it means that the program is correct. And this is the value. And this is the answer. Yay.
Okay. That was quick. That was quicker than even what I could muster this morning. Well, to be fair, I was also pre-caffeinated. Very nice. I mean, a very elegant way of making the code slightly more, I guess, more general purpose in that sense.
Yep.
But apart from that, yeah, you haven't coded yourself into any kind of corner here. In fact, that was a pretty easy refactoring to do.
Yep.
Anything else you want to show with this one? Otherwise, I'll just quickly show my solution.
I can think of ways we can refactor this code because it's a little too imperative. I think we can. Yeah, I don't know. We could do, like, you know, this improvement thinks it's infinite. You can just basically tinker with the code for as long as you want, and I don't think it's necessarily improves it. So let's look at your solution now.
Okay. But of course, if you throughout this have spotted an obvious improvement that really should be made, you can let us know in the chat here, of course. Right. So going back to it, we can see a lot of stuff that looks very, very similar, because this time, rather than just counting the reachable summits, of course, we count the distinct path to summits, which this code is exactly the same as what we had beforehand. And this is pretty much just a carbon copy of my original code. But I decided I'd introduce a new type, because now we have a list of paths rather than lists of summits specifically. Which just means that we now keep a list of paths, which is a list of vectors, and we just return those. I don't think there's anything particularly special here in this code. Again, this was like a 3-line change and like a little rename. Yeah, but that's about it. Yep. Which, you know, sometimes that's also quite delightful, because you do never know what you're in for with part 2. So it is sometimes a relief if it turns out it's a 6-minute and not a 600-minute part 2.
That's true.
Yeah, someone here has mentioned, Jelly has mentioned deep recursive functions, which I don't think we're gonna throw in here, because actually looking at the time, we've been going for quite a while. However, I do just want to quickly shout out the fact that it exists, and we can actually take a look here. I can post a link also to that documentation. essentially deep recursive functions if we were in a scenario, where we were going beyond the 9 elements, and we may actually have some very deep recursions, as the function name might suggest. Then we have the problem, or we typically have the problem, that we might just run out of the call stack if those don't happen to be tail recursive. If they're tail recursive, things are lovely, because in Kotlin we do have the tail rec modifier that actually rewrites your recursion into a loop as it gets compiled. So there, it's not a problem. But for the other scenario, you can use coroutines, I suppose, or the coroutine machinery inside of the compiler to create these deep recursive functions. And there you would just call your function using .call recursive rather than doing a direct invocation. And through magic, it gets rid of the problems that you would otherwise be facing by essentially making those calls not on the regular call stack, I suppose. Dima, do you have more about this? I'll be quite honest with you. I'm not sure. I don't have a deep knowledge of what's going on under the hood here.
Honestly, this is the first time I'm hearing about this API, so
hey, look at that.
Your information, yeah, I learned something today. Yeah, so your information is as good as what I can tell you.
Okay. I think there should be, there's a blog post from Roman Yelizarov about this as well, which goes a lot deeper into this, about iterating a tree. This website is very jumpy for me for some reason. But if you want to learn more, this is going to be your homework, your part 3, for everybody at home. So I have provided a link for that. And of course, the other homework is to make sure that you do check out the blog post about everything that we are doing with Advent of Code this year. Dima, it has been absolutely a pleasure to have you today. This was a really cool way of interacting with Kotlin.
Yeah, I was happy to be here. Happy to stay in touch with my former colleagues and be a little bit involved in the things happening around the language.
No, it's really great, and I think that a lot of people are also very excited to see you again here on our channel. If you ever want to appear in a guest video or something, you have my email address.
I do.
Speaking of videos, if you at home want to make sure you don't miss the last 2 streams that we have going, probably for this year, make sure you hit that notify me button on the Kotlin by JetBrains live streams tab, so that you will be notified when the next streams happen. Because there's only 10 hours and 36 minutes left until the next puzzle unlocks, and 12 hours after that, we will be back with another stream and another magnificent guest. I can very much encourage you not to miss it. It's going to be a good time. Yep. All right. Well, it is time to say goodbye. So thanks again, Dima, and thanks to everybody who has decided to tune in today and spend their Tuesday afternoon or Tuesday evening with us. I hope that you'll have a great time solving tomorrow's puzzle. And of course, I hope that we'll get to see all of you again then. All right. That's pretty much everything we have for today. So take care, have a lovely Kotlin, and see you tomorrow. Bye.
Bye.